Hello, so this is a video on how to use GAMS to solve a system of equation, so which could be written in this form, AX equals B. So if you have like 3x3 equations that you want to solve, similar to this kind of equation you can write the coefficients of the unknowns. You can write the coefficients in form of a matrix, then multiply by X, then equals B. So this X is basically the variable that you want to calculate. So your X, Y, and Z will be this vector, and then B will be the right-hand side. Okay. So the system of equation AX equals B can be solved in GAMS as an optimization problem. So that's one way you can solve it. You can also invert the matrix. If you write this matrix, you can find the inverse of this matrix, multiply by B, and that gives you this X. Now, if you formulate the problem as an optimization, you can use an LP solver, linear programming, basically. Even if the matrix A is not square, LP solver can still find a solution if there exists a solution for the problem. So what we need to do is to decide a variable to be optimized in the model. And this could be one of the variables in the model, or we could just optimize a dummy variable, a variable that is actually not part of the model, but we just introduce it into the model and try to optimize that, minimize it, for example, in order to be able to solve the problem, the equation that we have. Then what are the procedures? So what do you need to do? If you follow these steps, you should be able to implement these in GAMS. So first, define the required set, then define the matrices that you have. In this case, you have A and also a vector B. So this will be a vector and this is a matrix. You can use a table in GAMS to define a matrix. Then define the variable X and a dummy variable. So I want to call the dummy variable dummy underscore var in this case. Then you define and declare the equations to be solved. So we want to solve the equation that we have, which is basically, we write an equation from here, which is an equation. That equation can be written in this form. So we can find the sum over J of A multiplied by X, which is this AX equals B. So, the way you do the multiplication is you do column, then multiply by row, then you add them up. So that is what this sum is doing here. So that's how you do matrix multiplication, if you remember matrix multiplication. And then the other equation you want to solve is dummy underscore var equals 0. You just want to set that variable to 0. Then solve the model using LP and minimizing that dummy variable that we introduced. Okay. So let's see how you can solve this in GAMS. So we want to basically solve this system of equation and using this approach. Okay. So let's move to GAMS. Yes, I already implemented the code. So what I've done is to define a set I. So because I have 3 rows, 3 columns, so I just put the members of the set A1 to A3. Then I just copy that set. So I use alias because I know is the same number of rows is the same thing as is equal to number of columns. So I'll just use J for column and I for rows. So I just use alias instead of defining another set. So basically giving this set another name J. So then I define the matrix. So I can define the matrix using a table and then define the parameter B. So, the right-hand side in my equation, there are 2, 9, and 8. And these are the coefficient matrix for the equation. Then define a variable. So this is a variable I want to calculate X. And this is a dummy variable I introduced. Okay. Then define the equation. So this is the equation that I actually want to solve. So because I need to solve it for each set. And then for each member of the set, rather than the dummy equation, also is just the equation dummy variable equals 0. Then I've declared the equation, then I'm defining the equation. So this is the equation that I showed you earlier, sum over J of Aij multiplied by Xj equals Bi. And then the dummy equation, which is basically the dummy variable equal to 0. Then create the model, then solve using LP, minimizing the dummy variable. You display the result. I run it now. Then I can display the X value. So it tells me that X is 1, Y is 2, and Z is 3. Okay, so if we substitute these values, you will see that it's correct. I hope that helps. So I'll see you in the next video. All right.